Okay, today we will learn about the Kirchhoff voltage law, or we can say the Kirchhoff second's law. His voltage law states that for a closed loop series path, the algebraic sum of all the voltages around any closed loop in a circuit is equal to 0. This is because a circuit loop is a closed conducting path, so no energy is lost. In other words, the algebraic sum of all the potential differences around the loop must be equal to 0, as we can say summation of the voltage is equal to 0. Note here that the term algebraic sum means to take into account the polarities and sign of the sources and voltage drops around the loop. The idea by Kirchhoff is commonly known as conservation of energy. As moving around a closed loop or circuit, you will end up back to where you started in the circuit, and therefore back to the same initial potential with no loss of voltage around the loop. Hence, any voltage drops around the loop must be equal to any voltage source met along the way. So when applying Kirchhoff's voltage law to a specific circuit element, it is important that we pay special attention to the algebraic signs, means positive and negative sign of the voltage drops across elements and the EMF of sources, otherwise our calculation may be wrong. Now look at this circuit. Here we made the circuit with resistance and we have to find out the voltage drop. Here the sum of the voltage drop around the loop is equal to 0. When you begin at any point of the loop and continue in the same direction, note the voltage drop in all the direction, either negative or positive, and return to the same point. It is essential to maintain the direction either counterclockwise or clockwise, else the final voltage value will not be equal to 0. The voltage law can also be applied in analyzing circuit in series. Now take an example, a circuit. In this we apply the 6 volt and here we take a resistor of 2 ohm and 1 ohm. Here you can see the terminal of the battery and the label of potential of this point 0 volt. We go around the circuit in the direction of the arrow, which is the direction in which we think current will flow. On passing the battery, the potential increase by 6 volt to 6 volt. We then lose 4 volt on passing the 2 ohm resistor to give a new potential of 2 volt. Finally, the voltage drop by 2 volt in the 1 ohm resistor back to 0 again. Kirchhoff voltage law can be summarized in these situations as 6 volt minus, here we increase, we have a resistor of 2 ohm, so 2 ohm and the current is 2 ampere, and the next here we have 1 ohm resistor and the 2 ampere. From this we get 6 voltage minus 4 volt, which is drop at the 2 ohm resistor, and minus 2 volt, which get the voltage drop at the 1 ohm resistor, which is equal to 0. 6 volt minus 6 volt equal to 0 means voltage drop is total 6 volt. In this way, Kirchhoff's voltage law can be generalized to any loop containing any number of components. Thank you.